This video demonstrates how to run experiment studies with the ExperimentManager. We want to investigate how the availability of a machine affects the utilization of an associated auxiliary machine, which is going to take on part of the workload when the main machine is busy or failed. To do so, we create a model with a source, two stations representing the main machine and the auxiliary machine, and a drain. The main machine should be the first successor of the source. First, we connect the source and the main machine, and then the source and the auxiliary machine. You can insert the two connections from the two machines to the drain in any order you like. Then, we open the source to configure it. We want it to produce one part every minute. We click the tab Exit of the source and select the Exit strategy Start at Successor 1. We want to simulate interruptions of the main machine caused by failures. To do so, we add a new failure profile by clicking New on the tab Failures. We accept the default availability of 95% and the MTTR of 1 minute. MTTR stands for Mean Time to Repair. As we want to run experiments with the ExperimentManager, we need the simulation to end after a certain time. To enter it, open the dialog of the event controller. Check the tab Settings and type a termination time of 1 hour. 1: in the text box End of the event controller. Plant simulation will automatically expand the time to 1 hour. Click OK to close the dialog. This model is suitable for the intended experiment study. Finally, we add the ExperimentManager to our simulation model. You will find the ExperimentManager on the tab Tools in the toolbox. Open it and configure the experiment. We first specify the output values as the target of the simulation study. To do so, we click Define Output Values on the tab Definition. Drag the auxiliary machine to the first row of the table and drop it there. Then, we extend the name with the statistic value we are interested in. Stat, working portion, in our case. It's helpful to enter a description of the value, for instance, utilization of auxiliary machine. We then click Apply to run a plausibility check. It tests whether the entered value exists and is suitable for a statistical evaluation. To enter a further output value, we click into the table Output and press Enter. We click the main machine and drag it to the second row of the open table. We then place the cursor behind Main Machine, type in a period, and the name of the statistics value that interests us. Stat, fail, portion in our case. It's helpful to enter a description of the value. We entered the description, portion of fail time of the main machine. We then click Apply to run a plausibility check and click OK to close the table. Next, we reset and start the experiment run. The ExperimentManager executes 5 simulation runs with different random behaviors caused by the failure we entered. After the experiments are finished, an HTML report will open. Click the page Statistics of Output Values. The box plot under Evaluations of the Output Value, Utilization of the Auxiliary Machine, visualizes the observed values of the first output value. The box plot visualizes the fluctuations. Minimum and maximum are often considered for a simple evaluation and give intuitive representation of the variance. A more detailed evaluation is available on tab Evaluation of the ExperimentManager. Click the button Detailed Results to open a table of the numerical results. Typical statistic values of the observed output values, like the mean value and the standard deviation, are shown in numeric form. The exactness of the mean value is described by the confidence interval. Be aware that one cannot draw conclusions with absolute safety. One can only make statements about a stochastic model with a given confidence level. The confidence level tells us with which probability the true mean value of a measure is located within the confidence interval. The default value of the confidence level of the ExperimentManager is 95%. After using the ExperimentManager for a statistical analysis, we want to check out how the availability of the machine influences the utilization of the auxiliary machine. We'll change the availability of the main machine. To do so, we define the input value. We select the checkbox Use Input Values and click Define Input Variables. To enter an input value, we drag the main machine to the first line of the table Input and enter a period, followed by Availability. This activates the button Define Experiments. We click the button Define Experiments. In the table X-Table, which opens, we enter the value 85, 90, and 95 for the percentages of the availability, each in a line of its own in the column. We then click Apply. The first column will be filled with value true, denoting that this parameter will be used for an experiment. Click OK. This configures a new experiment study consisting of 3 experiments. Each experiment has 5 simulation runs, or observations. Now we're ready to execute our second experiment study to check out how the changed availability affects the results of the simulation study. Click the buttons Reset and Start. The HTML report opens after the experiments are finished. Change to the page Statistics of Output Values. We can view the results of the 3 experiments in one chart on the tab Evaluation. On the tab Evaluation of the ExperimentManager, we can choose to show min-max intervals or confidence intervals. The chart shows the number of the individual experiments on the x-axis and the observed values of the output values on the y-axis. It shows the expected relationship between the availability of the main machine and the working portion of the auxiliary machine. We see that increasingly, the availability of the main machine results in a reduced working portion on the auxiliary machine. Click the tab Evaluation of the ExperimentManager. Select Confidence. Comparing the confidence intervals shows that this effect is not statistically significant. In other words, the observed differences can be a result of the random behavior of the model. Further studies are needed. You can close the chart. To get results with a greater reliability, we must perform more observations per experiment. We change to the tab Definition and type in 50 observations per experiment. After the study, we check the width of the confidence intervals. Click the Reset and Start to run the experiments. After the experiment run will be finished, we select the tab Evaluation. Select Min, Max and click Show to open the chart. More observations obviously led to greater min-max intervals. We select Confidence and open the chart again. As it is well known, more observations led to a reduction of the width of the confidence intervals. We compare the confidence intervals and recognize a significant difference. In our study, these observed differences cannot be a result of the random behavior of the main machine. The differences are significant and based on characteristic properties of the model. If you have doubts, repeat the study with 500 observations. This concludes the video using the Experiment Manager.